Hello and welcome to this video on determining the equation of a straight line given a graph. So we've got two types of problems here. So the first one, we are given the y-intercept and we can clearly see it. And on the second one, we're given the coordinates of 2 points and you can't really see the y-intercept. So let's try it out. First question, determine the equation of this straight line. So these formulas should be given on your formula sheet. This is what we're going to work around. So an equation of a straight line has this form, y equals mx plus c, where we need to find m, the gradient, and c, the y-intercept. Now, I am just going to start off, c is the easiest thing to find, right? So I'm just going to immediately write down c is our y-intercept, which is -6. So that's done. Now, m, the gradient, can be a little bit trickier. So I would recommend that you go back and watch my video on how to find the gradient given a graph. But let's check this out. So to find the gradient, we just need 2 points on the line. And when we're given a graph, we can just draw a right-angled triangle. So drop a right-angled triangle between those 2 points. Okay, so let's do it. I might have to do it in a different color. So how do I get from the leftmost point to the rightmost point? So I run how many units? I run a physical distance of 2 units. And then I have to actually fall. So I have to fall, which will be a negative rise. So I fall this distance, which is 6 units. That must be negative. Okay, so I'll show you what I mean. This is how to calculate m. So can you see from your formula sheet, m is rise over run. Rise over run. And from our graph, we've got the rise is -6. So substitute that on your numerator. The run is 2. And -6 divided by 2 is -3. So that's our m value. So we've got c is -6, m is -3, and we've got our general form of a straight line is y equals mx plus c. So let's now substitute in m and c. -3x plus -6. So we're just going to say, take 6. So any equation needs to be written in terms of y and x. So you leave y and x in. Another one, equation of this straight line. First, write your general rule for a straight line, and then realize we have to find m and we have to find c. So the gradient m is on our formula sheet. M is rise over run. And even before that, we are going to just put in our y-intercept. Our y-intercept is where it cuts the y-axis at -3. Now, our right-angled triangle that we drop between our 2 points, let's work that out. So the 2 points that we use are just going to be the ones that cut the axis. Can you see that? And, you could make your right-angled triangle there, or you could make it up here, whichever one you decide. Now, I am going to, let's make it this one. So there's my little right-angled triangle. And how do I get from the leftmost point to the rightmost point? So I have to rise a physical distance of 3 units. Don't worry about that -3. We are rising 3 units. And then we are running along the ground 1 unit. So then we just substitute it in. So the rise is 3. So that's on the numerator. Run is 1. 3 divided by 1 is 3. And to write the equation of the line, let's substitute in m. So 3x plus, because that's m, c, which is -3. So I'm just going to say take 3. And that is the equation of our straight line. So let's keep flying through it. Okay, the equation of this line, what's going on here? Okay, I think my stomach just made a weird noise, sorry. So let's drop our right angled triangle between the points. It's a bit of a different one. They've given us a pair of coordinates here. Let's check it out. So, and here. Now, there's a pair of coordinates. It's 4, -1. So I just always write down, if I'm given a pair of coordinates, write x, y underneath it. So that means that the x value is at 4, which it is, that looks good. And the y value is -1, which means this point here has a y value of -1. So I'm just going to mark that in. And then it will make my life easier. So let's go back to orange. And okay, how do we get from the leftmost point to the rightmost point? This rise, let's look at it. We have to break it up. This rise is actually going to be, it's going to be a physical distance of 3 plus that 1. But we are not done yet because we are falling as we go from left to right. From this point to this point, we are falling, so that rise must be negative. So if you're given a pair of coordinates, just mark them in on the axes, mark in. Okay, now we are running across the ground 4 units. Okay, now we've done the hard work. Gradient can be scary, but it's fine. So y equals mx plus c, and we've got to find m and c. The gradient is rise over run. The rise was -4, the run was 4. So that's our m value, and we can do c down here. C is where it cuts the y-axis at 3. Looking nice, but we're not done yet. We need to actually substitute it back into the equation. -x plus 3. Okay, checking out this. Determine the equation of this straight line. So here, it's kind of tricky to drop a right angled triangle, right? So, I mean, you could do it, but I reckon we know a formula where if we're given 2 points, we can find the gradient. 2 pairs of coordinates. All right, so I'm gonna label these pairs of coordinates. You could label them different ways, but this is what I'm gonna do. x1, y1, x2, y2. This is the formula if we're given 2 pairs of coordinates. Okay? So, well, first of all, I should have written my general form of a straight line, y equals mx plus c. And then I'm going to find my gradient using just the other formula for gradient. Over x2 take x1, and then carefully substituting y2 take y1. So we've got 2 take -2 over x2 take x1. So it must be in that order. -1 take -4. And then we know that 2 take -2 changes to a plus sign. So 2 plus 2 is 4 on the numerator. -1 plus 4 will give us +3. And that's going to be our gradient. It's a fractional gradient. Okay. And then what's our C? So we've done the hard work of gradient. Our C, oh no, I can't see C on here. There's no value. What do I do? Well, we are going to we're given a point, right? We're given a couple of points on the line. So let's actually look at our equation so far. It's going to be y equals 4/3 x plus c. It looks like, okay, 3 unknowns. What on earth am I going to do here? But we have an xy point on that line. So just choose any of these points and we're going to substitute them in and find c that way. Okay, so I'm going to say sub -1, 2, whichever point you want, because that's x, y. You always want to label your points. So I'm just going to say y equals 4/3 times -1 plus 2. Is that right? No, that's not right. Plus c. But on this side, we've got a y. So I'm going to substitute in 2. And now we've only got one unknown here. So we've got 4/3 times -1 is -4/3 plus c. And into your calculator, really. So we're going to add 4/3 to both sides. 2 plus 4/3 gives us 10/3, which if you convert that to a mixed number, we'll get an idea of where that lies on that y-axis. So 3's are 9. I'm just 10 divided by 3 is 3 with 1/3. And that makes about sense because it's positive. So, long story short, let's substitute those back in now. So y equals mx plus c, y equals 4/3, which was our gradient. 4/3 x plus, let's say 10/3. 10/3. And that's our equation. All right, so y equals mx plus c and is the general equation of a straight line. We know we need to find m and c. Now, I cannot see a y-intercept on here. So, but don't panic. We know that we can do this. Let's find our gradient because we've got 2 points and we know that there's a gradient formula for 2 points. So let's label our points x1, y1, x2, y2, and then carefully write your formula. y2 take y1 over x2 take x1. And we've got y2 is -4 take y1. Let's make that a bit straighter. x2, 3 take -6. So -4 take 1 on the numerator. So simplify 3 and that becomes a plus. 3 plus 6 is 9. And put a box around it if you like so you can find it easier. Okay, and now see, we look here and we can't see a y-intercept. But then we know that we're also given 2 points. So let's just write our line first. How does it look so far? We've got y equals -5/9 x plus c. Looks like lots of unknowns, but we know that we have an xy point on that line. So we're going to substitute in -6, 1, x, y. And we're going to keep going. And let's move this formula sheet down. Oh, that will do it. Substitute. So we've got an xy point. The y is 1, -5/9 times -6 plus c. And simplify. Where's my calculator? -5/9 times -6 gives us 10/3 plus c. And then we are going to subtract 10/3 from both sides to leave c by itself. So 1 take 10/3 will give us -7/3 as our y-intercept. And then we can write our line. So it's okay. y equals m, which is negative 5/9, x plus c. So take 7/3. And yeah, okay, so don't panic if you're not given the y-intercept. You have this information, x, y, and if you have your gradient, you can substitute that into and see what you've got. And I think that's about it for you. And sorry, that went a little bit overboard. So next video, we are also going to look a little bit further at determining the equation of a straight line given gradient and a point. So we're not given a graph this time, but just more work on when we have gradient and an xy point. Okay, I hope that was helpful. If you've made it this far, well done. Your attention span is good. All right, I'll see you soon.